In this video, I'm going to review question 10.2.17, which is number 8 in your 10.2 homework. Listed below are systolic blood pressure measurements obtained from the same woman. Find a regression equation, letting the right arm blood pressure be the x variable. Find the best predicted systolic blood pressure for the left arm, given that the systolic blood pressure for the right arm is 90 mmHg. Use a significance level of 0.05, and you can see a table here with our right arm and left arm values representing our x and y values. The first thing we need to do is put our values into our calculator. So x represents the right arm and y represents the left arm. In our calculators, that would mean our right arm values we're going to plug into list 1, our left arm values we're going to plug into list 2. So let's go ahead and do that. In my graphing calculator, I'm going to press stat and press enter on edit, and I'm going to clear what's in my list 1 by highlighting it, pressing clear, and then enter. Now in list 1, you're going to type in all of your values for the right arm. Go ahead and do that, and we'll check in together. Remember, you're going to type in the number, so for the first one, 1, 0, 1, and then press enter before doing a new line. Once you have all your right arm values typed in to list 1, take all of your left arm values and type them into list 2. So you'll scroll over, and if you have anything in your list, you'll scroll up, press clear, and enter to clear your list 2, and then you can type in the values. It's very important that once you have your data in list 1 and list 2, just double check to make sure you don't have any typos, because if you have typos, you'll come up with the incorrect answers, even going through all the correct procedures. So make sure you double check your numbers. Let's go ahead and find our regression equation now. We're going to press stat, go over to calc, and then you can either press the number 8 or scroll down to 8 and press enter. I'm just going to press 8. And that's linreg a plus bx. We have all of our x values in list 1, which might already be there, but if it's not, press second and then the number 1 to get list 1. All of our y values are in list 2. It might already be there, but if not, press second and then 2 to get list 2. We didn't use a frequency list, so that should be blank. We can store our regq by saying vars over to yvars. Under function, you can list it under y1, that would be fine, and now press calculate. And here you'll have our linear regression equation. It should be y hat equals 66.045 to 3 decimal places plus 1.031x. So go ahead and type that in. The problem actually asks us to round to just 1 decimal place, so you would get y hat equals 66.0 plus 1.0x. For the next part of the problem, we're asked, given the systolic blood pressure in the right arm is 90 millimeters Hg, the best predicted systolic blood pressure in the left arm is blank mmHg. So we have to say if x is 90, what will y be? In order to find this, we have to first determine if our data makes a good linear model. Let's go back to our graphing calculator, and I'm going to just write down our correlation coefficient R that we came up with, and it was 0.852. So I'll write R equals 0.852. And now let's go ahead and we can actually look at a graph of our data to see if it even appears linear to us. Now to get a graph of our data, we're going to go second, stat plot, and make sure your first stat plot is on. If it isn't, make sure that the scatter plot picture is highlighted with list 1 and list 2, and then go ahead and press zoom 9. What zoom 9 does is it gives you a good window. Now we don't have a lot of data, so it's kind of hard to tell if it's really a great linear fit, but it does appear to be somewhat to have as x increases, y increases, so that supports kind of a positive correlation, and R is 0.852. Let's test our R value versus the critical value on the Pearson correlation coefficient chart. So on the problem, it says click the icon to view the critical values of the Pearson correlation coefficient R. You have this chart in your notes, but you can also click it on the problem. Now we have 5 data values in our chart, and we're asked to use alpha equals 0.05, a 0.05 significance level. So what we're going to do is we're going to see where the 5 and the 0.05 meet. and that's at 0.878. So we need to compare our R, which is 0.852, to the critical value. I'm going to put CV for critical value of 0.878. Make this comparison, two different things could happen. The absolute value of R could be greater than the critical value. If that's the case, then we say that there's a linear correlation. If there's a linear correlation, what do? You plug X into your equation you came up with to solve for y hat. You could have your absolute value of R be less than or equal to the critical value. In that case, we don't have enough evidence to support a linear correlation. So we'd say there's not enough evidence for a linear correlation, so no linear correlation can be assumed in this place. What do you do in that case? You are going to find the mean, or the average of the y values. That's called y bar. So let's see what we have in our case. We're comparing our R is 0.852. Well, the absolute value of R would also be 0.852, right? So 0.852 happens to be smaller than 0.878. So we have the second case here. That means we need to find the average of our y values. The y values are the values given by the left arm. So what we need to do to find the mean or average is to add up all these numbers and divide by the total or number of items. So the sum of the items over the total number of items gives us our mean y bar. So let's do that. We come up with a sum of 789 over 5 for 5 items, and that gives us a mean of 157.8. What does that mean? It means that if x equals 90, we can predict that the value of y will be 157.8. You can type that into your answer place to complete the problem. I hope you found this helpful. Feel free to email me if you have any questions at all.